In this lesson, we are going to answer when is it appropriate to make an inference about a population, and when is it appropriate to make an inference about cause and effect. So we started this unit with talking about randomness and the importance of randomness. So when it comes to sampling, the whole purpose of randomly sampling is so that your random sample should be representative of the population so that we can generalize our conclusions from the sample to the population. In other words, when we take a simple random sample, notice the shape of this. This is showing you that it's a smaller version but representative of our population. Whereas when we take things like a convenience sample or voluntary response sample, these are not good sampling techniques and they do not produce samples that are representative of our population. So if we do randomly sample, we can then make an inference from our sample and apply it back to our population. Now, just another important concept to think about would be your sampling variability. Every sample that you pull is going to be a little bit different when we measure our statistics. You have a sampling distribution. So there is sampling variability. They're just going to be a little different. So different random samples of the sample population produce different estimates. But the larger random samples tend to produce estimates that are closer to the true population. So, the larger you can make this, the closer it is to the true population, is what I'm saying. Now let's think about the purpose of random assignment. So random assignment is referring to an experiment. We use random assignment in an experiment to create typically two groups that are roughly equivalent. You could have more than two. So that if there is a difference in the response variable at the end of the experiment, we can say that treatment caused the change. So here we're starting with 44 students. We randomly assign them to these two groups and we rely on the attributes of randomness to produce these roughly equivalent groups so that if we do have some sort of difference at the end, we can say that that was due to the treatment. So often you're going to be asked what the scope of inference is. So when you see this phrase, it refers to the type of inferences or conclusions that can be drawn from a study. The types of inferences we make, inferences about the population and inferences about cause and effect, are determined by the two factors in the design of the study. These two factors, or two things you need to ask yourself, would be, were the individuals randomly selected from a population? If we can answer yes, then we can make an inference about the population. If not, then the best we can do is only apply it to that sample. Were the individuals randomly assigned to groups? If they were, then we can draw conclusions of cause and effect. If they were not, the best we can say is, maybe there was some sort of correlation, or association would be a better word. Correlation should only be used if it is linear. So let's talk the perfect scenario where we can answer yes to both. So were individuals randomly selected from a population over here? If we can say yes to that, then we can make an inference about the population. If they were randomly assigned to groups, we can also say yes. Now, I need to tell you that though this is like the perfect scenario, this rarely occurs. Okay, real life, it's difficult to randomly pull people from a population. Like, think a medical study. You can't just randomly select people and get them to be part of an experiment and then randomly assign them to different treatments. It's often not going to work out that way. Let's look at this scenario here. What if, individuals randomly selected from population. If we say no to that, so can we make an inference back to the population? No way. But if we say yes to random assignment, which typically we can do once we have our sample of participants, we can say yes. So I'm going to tell you that most experiments fall right here. And now when I'm over here in this column, if I'm answering no to random assignment, then I'm probably not even talking about an experiment, because if I'm not randomly assigning, then why am I even trying to do an experiment? Because then I can't do cause and effect. So these two cases are probably talking about an observational study. So to answer this now, up here top right, so if we say yes to random selection and no to random assignment, we could make an inference about a population, but we could definitely not make one for cause and effect. So if we're saying no down here, this is also going to be no to cause and effect, but if I'm saying no to random selection from your population, these are both going to be no. All right, so let's look at this example shared by StatsMedic. So some students at your school claim that listening to music while studying will help them improve their GPA. Design a study to help discover if this claim is true. Now, I'm going to show you 4 proposed studies for investigating this question. Suppose we found that the mean GPA of students who listen to music is significantly lower than the mean GPA of students who didn't listen to music. What conclusions could we make? So, can we generalize to the population, and can we determine causation? So the first scenario would be you get all the students in your statistics class to participate in a study. Ask them whether or not they study with music on, and divide them into 2 groups based on their answer to this question. So as I look at this, I answer first, did they have a random sample? I would say no. This to me seems like a convenience sample. And then random assignment, no. Definitely didn't do any random assignment here. So what conclusion can I make? So I begin by stating who I can generalize this to. Since I did not have random selection, I cannot generalize it to a population. So it only applies to my sample. So what was my sample? It was just the students in the stat class. So I say, for all students in the AP Stats class, there is an association between listening to music while studying and lower GPA. So I can't say causation here because I didn't have random assignment. And I finish it by saying, because there was no random selection, the results can only be applied to the sample. So a second scenario. Select a random sample of students from your school to participate in a study. Ask them whether or not they study with music on, and divide them into 2 groups based on their answer to this question. So this is looking a little better. They did create a random sample, which means I'm going to be able to generalize this to the population. But was there a random assignment? No. So here's how I'm going to state this, but I'm going to include my 2 big things here. I'm going to be able to generalize this to my population, and I am going to not be able to make any type of cause and effect. The best I can do is some sort of association. So I also want to recognize, so what's my population here? I would say it would most likely be students in the school. You couldn't generalize it broader than that. So this statement I'm saying for all students in the school, so there I've generalized it to the population, there is an association between listening to music while studying and lower GPA. So I haven't claimed cause and effect. All right, so now what if you get all the students in your stat class to participate in a study? You randomly assign half of the students to listen to music while studying for the entire semester, and have the remaining half abstain from listening to music while studying. So, did you have a random sample? I would say no, because you're just, again, a convenient sample. Was there random assignment? Yes. So, we are going to be able to state cause and effect this time. However, we are not going to be able to generalize this to a greater population. So I'm going to state that for all students in the stat class, there's my sample, music while studying caused a lower GPA. In our 4th scenario, select a random sample of students from your school to participate in a study. Randomly assign half of the students to listen to music while studying for the entire semester and have the remaining half abstain from listening to music while studying. So, do you have a random sample selected? I'd say yes, so you will be able to generalize to your greater population. Was there random assignment? Yes. So now we're going to be able to do what we want. This is like our perfect scenario, which rarely really happens. We can generalize to a population and show cause and effect. For all students in the school, music while studying caused lower GPA. Finally, I want to briefly talk about ethics and proving causation when it's really difficult to design an experiment. This is not a tested subject on the AP exam, but it's really very important. So think about questions like this. Does going to church help people live longer? Does smoking cause lung cancer? Does texting while driving increase the risk of having an accident? While we think we know the answers maybe to some of these, like texting and driving, can you really design an experiment with random assignment? Are you going to randomly assign some students or people to text while they drive and others to not? Is that ethical to do that? Hopefully you're saying no. You're not going to make one group smoke cigarettes and another group not smoke cigarettes. So we know that to prove cause and effect, we just need to perform a randomized comparative experiment. But unfortunately, we can't randomly assign people to attend church or to smoke cigarettes or to text and drive. But it is sometimes possible to build a strong case for causation in the absence of experiments. And I think that the lung cancer and cigarette example in our country is a very good example. It was so hard for years and years to bring a valid case against the tobacco industry because they used the statistics to their advantage. They knew that a strong association did not necessarily mean causation. So though there was much evidence that those who smoked were getting lung cancer, was it truly proof that smoking caused the lung cancer? So it took a long time in the court of law for this case to be settled or to be won against the tobacco industry. So some of the criteria for building a strong case for causation in the absence of the experiments is shown on the screen. So you have to have a really strong association. And then in purple here, I kind of have some notes about the smoking case. They prove that the association between smoking and lung cancer is very, very strong. The association is consistent. So they had many studies of different kinds of people in many countries linking smoking to lung cancer. So it wasn't just exclusive to one part of the world. That reduced the chance that some other variable specific to one group or study could explain the association. Larger variables of the explanatory variable are associated with stronger responses. So they've discovered that people who smoke more cigarettes per day or who smoke over a longer period of time would get lung cancer more often. And then again, the alleged cause precedes the effect in time. So they found that lung cancer developed after, years and years of smoking. And the alleged cause is plausible. They found that experiments with animals show that tars from cigarette smoke do cause cancer. So where it would be unethical to do it in humans, there was an experiment performed with animals. And though some might say it's a leap to make the conclusion with humans, all of these criteria together make it possible to show causation. Now, it's not always a black and white area when it comes to ethics. Oftentimes, there's this very gray area in between. This boundary between the ethical and unethical is not this clear, distinct line. So there are some basic things that that we talk about when we look at ethics. And this would be that all planned studies must be reviewed in advance by what's known as an institutional review board or an IRB, who are charged with protecting the safety and well-being of the subjects. And most universities have an IRB board, so even in class, if we would be doing some sort of experiment, we would need to submit our proposal to one of the local IRBs. All individuals who are subjects in a study must give their informed consent before data are collected. And then all individual data must be kept confidential. You can only report statistical summaries for groups of subjects to the public. So again, these are not topics on the actual AP exam, but really important things to consider.